Hey, Hammy here, coming to you with the first video from Chapter 2, where we are going to do a little bit of chemistry. We're going to look at what is matter, and then we're going to focus on this idea of organic compounds or the molecules of life. So this first video is going to be a little bit of review of other science classes, especially physical science, and a bunch of the chemistry you did there. We'll talk about atoms, periodic table, and some bonding. Okay, one of the first things is we'll define what a chemical substance is. Most of us have seen this definition before for matter. Matter is anything that has mass and takes up space. Sometimes by take up space we mean volume. So it has mass and takes up space. Or has mass and volume. So this would include solids, liquids, gases, okay, even air. Okay, and then of matter, we start to classify them or categorize them into elements. Elements is an element is a pure substance that cannot be broken down into another substance. It's the smallest particle of that substance that still has properties of that substance. For example, over here we have oxygen. Okay, oxygen has an atomic number of 8 and atomic mass of 16. So if you look at it, you've got 8 means it's got 8 protons. So in here you'd have 8 positive protons, and I won't take time to draw them all. Okay, and then 16 minus 8 for the mass gives you 8 neutrons. So you're going to have 8 neutral neutrons in here. Okay, I guess I'll finish the protons here if you make me. Okay, so you got, that gives it a mass of 16. Okay, now also if you have 8 positive protons, you're going to have 8 negative electrons. These things here in the outer level are electrons. Remember, we can, in our levels, at least in biology, we'll put 2 electrons in the first level. Second level can hold 8. And in our biology class, we won't go more than 8 in the third level. Okay, so you can see here that the first level is smaller, so that there's 2 electrons in the first level, and then we need, it has 8 total electrons, so you need 6 more electrons. We got 1, 2, 3, 4, 5, 6. Okay, so 6 plus 2 gives us our 8 electrons, our 8 negatives, to balance out the 8 positives in there. Okay, now these outer shell electrons right here, okay, these outer electrons are what we call, and you've learned this last year, are valence electrons, and they are important because to be stable, okay, that outer shell or valence electron is going to have to be 8. 2 if it's the first level, 8 if it's the second, and 8 for most of biology for the third level. Okay, and when we talk about bonding here in just a minute, we'll look at these valence electrons again. Okay, so this is an atom of oxygen, sorry, and it will always have 8 protons, okay, and 8 electrons to make it electrically neutral, and usually 8 neutrons. There are such things called an isotope, which you'll learn about in chemistry. Isotopes are atoms of the same element, like oxygen, that have maybe more or less neutrons. So that will affect their mass, but not a lot. It won't mess up the valence electrons and some of the bonding properties. All these chemical elements are organized into a chart we call the periodic table. Okay, the periodic table is really helpful. You think, well, that's kind of a funny shape. But it's really organized into columns or groups that go up and down, and all of these elements in this group will, and all the way across, will have similar properties. Same thing here. These rows are called periods, hence the periodic table. And each period, each row, you'll see general patterns. And as you get into chemistry and study the periodic table more, you'll learn about the alkali metals, the alkaline metals, the transition metals, metalloids, halogens, the noble gases, all of those things, and there's certain properties where you find it on here. But this chart is important for us because, for example, it's showing us iron here. Okay, and a lot of periodic tables will show us the chemical symbol. Okay, 2 letters. First one always capitalized, second one always lowercase if there is a second letter. The element's name. Okay, it'll tell us the atomic number, and you'll notice that 1, 2, as you read across the rows, the atomic number is in increasing order. And the atomic mass, which tells us the number of protons and the number of neutrons. So the periodic table is a handy way of just kind of organizing all the elements that we know of, and a reference table that we can look up different properties. When atoms from different elements combine, they'll form what we call a compound. Okay, that's 2 or more elements combined together. Sometimes like O2 or N2 or H2, oxygen gas, nitrogen gas, hydrogen gas. Those are 2 of the same atoms bonded together. Always definite proportions. For example, down here we have an oxygen with 2 hydrogens. Okay, that we commonly know as H2O or water. Okay, water is always 2 H's, 2 hydrogens, and an oxygen. Always. Okay, that's what it means by definite proportion. Okay, these small things that still have properties of water, the smallest thing that you can have that is still water is considered a molecule. Okay, a molecule of water. Molecules are formed through bonds. Okay, bonds are interactions of electrons between 2 atoms. There's 2 types of bonds that you have discussed last year. Ionic bond. What happens in an ionic bond is, for example, sodium. You see sodium, they're just showing the valence electrons here. Okay, and you see sodium has just 1 electron, very unstable. Chlorine, okay, has 7 valence electrons. It just needs 1 more. See this empty spot right here? If it just have 1 more electron, it could be stable. So the electron from sodium will jump ship, and you can see this in this little GIF here. You see the electron from sodium jumping ship over to the chlorine. Now what happens is you've given chlorine an extra negative charge, so it becomes a chlorine ion. And because sodium lost a negative, now it has 1 extra positive proton. You have a positive sodium ion. Okay, so the electrons are transferred, making this sodium a positive ion and chlorine a negative ion. And like in the kind of in the dating world, opposites attract. So you have a +1 and a -1. They are then attracted and they stick together. So because of that transfer of electron, the sodium and the chlorine stick together, and we get sodium chloride, or what we commonly know as table salt. That's an example of an ionic bond. The second type of bond is called a covalent bond. A covalent bond are when electrons are shared. Okay, so again, coming back to oxygen here, you see we have 1, 2, 3, 4, 5, 6. Okay, and remember in the outer shell it can hold 8, so it has an empty spot here and an empty spot here. Hydrogen over here has 1 electron here, and then if it just had 1 more electron here, it would be stable, because remember this is just the first level here, can only hold 2 electrons. So what it does is it cozies up to oxygen and it shares this electron here, and another hydrogen cozies up to this spot down here. So over here you see this hydrogen sharing here and sharing here. So that electron spends sometimes spinning around the hydrogen and sometimes spinning around the oxygen. Okay, it spends time around both atoms. They are sharing, and that forms a covalent bond that we call water, H2O. A structural formula that we often write looks like this, with a letter and then lines to represent a pair of shared electrons right here. Okay, so you have two shared electrons here and here. Okay, that is a covalent bond. Okay, so that wraps up this first video. Just kind of review of what you should already know from physical science last year. Next video we'll begin to look at some carbon-specific compounds that are very important in the area of biology.